Hello, ladies and gentlemen. Thank you for tuning in to another wonderful webinar series here at ACI Learning. I am your host, Bryan, and I am here with Mr. Anthony Sequeira, and we're going to be looking at software-defined networking, and I'm really excited about this because, well, it's a buzzword, but sometimes it's clouded in mystery, and here to help us out with that is Anthony Sequeira. Anthony, thank you so much for being here. I'm really looking forward to this topic because as we talk as instructors, this can be one that's kind of challenging to teach, and I'm glad that ACI has given us the chance, ACI Learning has given us the chance to kind of explain this to you, and we're glad you're here. So Anthony, thank you for joining us. Where do we get started in this topic?
Yeah, let's jump in. And Wes and I were chatting before the live webinar started, just talking about how it's really going to be nice to have about 35 minutes to talk about SDN, because a lot of instructors out there aren't given that kind of time to talk about this one very important subject. And something else that I find out there is a lot of students are troubled by this topic, either because they don't understand it or it's been explained to them in such an overly simplified way that they start having all these concerns about maybe even do they have a job and things of that nature. So let's deep dive a little bit into SDN. And before we really get too far, let's talk about something that's critical that you understand here, and that is how Wes and I think when we look at a network. Wes and I look at a network and we immediately begin compartmentalizing that network into what we would call planes of operation. What's an example of that? Well, probably the one that most people think of, and that is the data plane. So when you look at your network, understand that there is user traffic moving through that network. And that is what all of us really just appreciate the network for. Its ability to move end user traffic from location to location at a speed as possible. Notice I say here that we are discussing traffic moving through the network devices. The contrast to that would be, well, how about the management plane where we communicate to a device, not through it? So this is kind of the standard thing we think about with the network, this important data plane. And speed, and speed are the big important things here. So you'll often see the data plane handled with firmware, with specialized software in very fast operating circuits on the devices to get that user traffic through as quickly as possible. Now, the management plane, I just mentioned it, is also going to be a critical area of operation for us. And this is how we're going to configure and manage and monitor and maintain the gear traditionally. Now, kind of giving us a preview of things to come was the taking of the management traffic and moving it out of band. Yeah, administrators started to realize, ooh, my goodness, we've got all this highly sensitive, oftentimes, management traffic. Perhaps it's not a great idea to be moving it along the same data plane of operation. So one of the precursors to full-blown SDN, I kind of envision it as, taking the management traffic and moving it out of band. Now, management plane traffic, by the way, typically we're really interested in treating it with very strict priority and very strict security. If you're sending configuration commands down to a device, the last thing you would ever want is for someone to be able to intercept those commands and learn about how you're configuring the network device.
So high security, we got to worry about things like those man-in-the-middle attacks, right? Somebody's scraping that information off of the network.
Absolutely. Mm-hmm. And you know, Wes, you just made me think of another one, denial of service attacks.
Oh, sure, sure.
I mean, if we're not thinking about separating these planes of operations, someone could come along and just start flooding the machine with fake management traffic and squeezing out that user traffic. So yeah, let's give the management plane high security and strict priority. Now, one that Wes and I think about probably more than any of these other planes of operations, end users wouldn't, and students new to this discipline probably wouldn't, but Wes and I become obsessed with the control plane. This is like the intelligence of the network. A great example here is in a routed environment, maybe we're running open shortest path first, or OSPF, as the routing protocol. Well, sure enough, that is part of the control plane operations. We mentioned the data plane has our end user traffic racing through our network topology. Great. But how does it know how to do that? How does one router know how to send certain traffic one way and other traffic another way based on maybe IP address? Well, the control plane information is what makes that a reality. Notice this would include things like spanning tree protocol and rapid spanning tree protocol and bidirectional forwarding detection, and all of these. I guess I just thought of this, Wes, kind of a way we can describe them is they are supporting protocols in the control plane to support and make the network do what it is we want it to do. Now, we said that the data plane, we were obsessed with speed and the components were really optimized that way. In the control plane, I really like to describe it as optimized for customization. In other words, OSPF makes it very easy for you to go in and re-engineer the network. There's special area types and special router types that we can use to optimize things. So a lot of customization is possible here.
And let me think about that real quick there, Anthony. That control plane really allows us to drive our networks towards the customization that is business driven. Like what the business needs, that control plane can allow us to accomplish that.
You better believe it, Wes. In fact, we have another popular kind of, this is cutting edge now for networks today, but it's intent-based networking.
Okay.
And that is very much about intent-based networking is very much about, okay, what does the business need?
And the mindset here is that SDN's driving that functionality.
Something else that's critical about this, and I always used to beg students to listen to me on this and even beg decision makers in companies to listen to me about this. We shouldn't be implementing technology just because it's the new hot thing, right? Oh, there's a new tech out. You know, AI would be a great example of that. I'm thrilled that here at ACI Learning, we're being super careful about adopting AI.
Yeah, sure, because your tech stack can get out of control really quick. And then you have a lot of stuff that could be unvetted and maybe is absolutely useless.
Yeah.
Right? Well, we don't spend money just to spend money.
Yeah. I mean, when we were talking AI, our leadership team was like, okay, what's out with AI right now that can benefit our instructors? Okay, let's take a look at that. What's out there with AI that can benefit our students, right? We're not just running out and adopting technology because it's there. We should always have a darn good business reason as to why we're doing something. Well, all right, let's get back to our story now. We have these different control plane, data plane, and management plane, and you probably know where this is going. The way we were.
All right, I have to say it. It's probably going to come out. Back in my days, we used to walk to school uphill in the snow both ways, right? So let's take a trip in our proverbial time machine, 88.5 miles an hour, and we're going to go back in time. Tell us the way we used to do it.
Yeah, the way we used to do it, as you might guess, unfortunately, was everything was done together. Here I have an illustration of it. We can see traditional networking. Here's Wes and I making a connection, literally making a connection to each and every device. And there was this complete just melding together of management plane traffic, control plane traffic, data plane traffic, and management really was the issue.
So this is the opposite of the benefits that we get with software-defined networking because it's not as agile, right? So if let's say a business decision does change and we need to change the intent behind our network, you and I We have to go to every single machine to make that a reality.
Yes, and also I can tell you this from a Cisco networking example, and I apologize, everyone. Cisco is very much my bias, although I'm certified in other networking vendors. Most of all my certs are in the Cisco realm, but suffice it to say, they all face the same issue. When you have everything meshed together like this, you need to come up with security protocols and QoS methodologies so that things don't get starved out. In Cisco networking and other disciplines, we have management policing or management plane policing. We have control plane policing. We have all these mechanisms that we have to worry about with all of this thing comprehensively together. Now, here's a look at it. The control plane, the data plane, the management plane all together. Now, as I did indicate earlier, though, one of the things we started doing a long time ago was realizing, oh my gosh, the management plane should be separate. And one of the ways that we would do that, as we indicated earlier, was with out of band or OOB management.
So like, for instance, let me give you an example and see if this fits, like an ILO, right? The integrated lights out, that would be in your HPE devices, right? Where I could connect over from my house and connect directly into the network adapter, regardless of what's going on in the operating system.
Yeah. One of the tricks that Cisco started doing was, it used to be a separate out of band management port. And then they got smart and said, look, pick any one of these 8 gigabit Ethernet ports, you will go into the software and dictate it as a management only port. So it's great that we were thinking, all right, let's get these planes separated.
Okay, sure. So we've got some kind of decoupling here, but it's not enough. Tell us a little bit more.
Yeah, now we're going to move into truly the world of software-defined networking, where we get very, very intense about separating these different planes of operation. Let's take a look at the software-defined network that we are so excited about today. First up, well, sure, there must be a data plane still. And notice all those physical devices that we've been giving examples of here are in that data plane. They're all really able to focus on their job, and that's moving data through the environment as quickly as possible. So where is the control plane? The control plane is now separate from that data plane, and inside of that control plane, you can see I've kind of represented it as just this kind of networking gadget. Well, that is a controller. So one of the things that makes software-defined networking is there's what we call an SDN controller that is the central intelligence for getting things done in our environment. Now, I just want to caution you about something. I show it as a single box, but just remember that it might be primarily a software component. So it doesn't have to be a physical box. It may be multiple physical boxes or multiple virtual components. The beautiful thing about software-defined networking, among many things, is that there is no one way. Sure, there's reference architectures and white papers that you can read about and things of that nature. And yes, there are open standards here, but it doesn't have to be that way.
Let me ask you about that data plane here as we're starting to decouple them, because the one thing in the traditional way I know we would do, speaking of your certification, Cisco, right? You have multiple certifications from different vendors and stuff. In the old days, we would get vendor locked, right? How does software-defined networking help across different devices? Do we abstract that away, or can we?
Yeah, that's the tricky part of this, I'll be honest.
Okay.
In the future, I think we're going to see this be more vendor agnostic, vendor neutral. But for right now, a lot of the vendors are having solutions that are very specific to them.
Okay.
So we'll be showing off an actual SDN solution here in this webinar, and we'll pick Cisco. We could have picked Juniper. We could have picked any of them. But yeah, for right now, they are quite siloed to their own gear. Yeah. So we have the control plane and the data plane. Let's add a plane of operation to SDN that we have yet to speak about. So let's take a look at that. And it would live traditionally in our illustrations above the control plane, and it's called the application plane. What the heck is this? Well, what this is typically really impressive graphical user interfaces that engineers can use to manage and control their equipment. This is really the component that gets us as administrators excited, and this is really what we're going to be showing you in a few moments when we take a look at Cisco's, we're going to choose Cisco's SD-WAN, which is a software-defined wide area networking tool that's very popular. Now, where's the management plane? Well, it's interesting. The management plane is separate still, of course. It's out of band and separate, but it's not really needed all that much. Let me explain. We may use the management plane to initially prep some of those devices, and we need it to initially prep the controller. But then the management plane is basically off the hook, because administrators will be working up in their application plane, making changes, monitoring. That flows down to the controller, which flows down to the network devices. So the management plane is really there and becomes a nice kind of backup alternative to managing this through software-defined networking.
You know, one of the things that I had to do in the early days of starting to teach is I had to teach back in the days of like the HAL, the hardware extraction layer, the abstract layers, but then we would have to fill in the blanks, right? Where does the operating system talk to the hardware, and we would fill in the drivers? Where do the applications talk to the operating system? And then finally we call it layer 8, the user talking to the operating system. How does the communication happen within this infrastructure?
Yeah, great question. So one of the exciting things about software-defined networking is how these key layers are going to be able to communicate. And let's fill that in. Notice there's two things that I would really like you to know here, and they are the Northbound APIs and the Southbound APIs. And I'm not making that up. It sounds kind of something like something I would have made up, but that is the official terminology for these APIs. API stands for Application Programming Interface. And Wes and I were talking before this webinar began, and we agreed that so many students out there keep seeing this three-letter acronym and really don't get it. They don't understand it. So we're going to make sense of that for you next. But for right now, I just want you zeroed in on the fact that APIs are the lifeblood of this system. This is how these layers are going to be able to communicate. And notice north and south is in reference to the controller. So
get out your proverbial compass, and if you can remember north and south, you know which layers are talking to each other. Very good.
So when we hear Northbound API, we should be able to go, oh, that's the applications talking to the controller. When we hear Southbound, oh yeah, that's the controller talking to the devices. Kind of get those distinct.
Northern point of your stack versus the bottom portion of your stack. Yes. That's interesting.
And you talk about standardization. Obviously, all these vendors draw SDN the same way, or that wouldn't make sense, north and south.
Oh,
they all show the controller in the middle, the devices down the bottom, and these applications up top. Mm-hmm. Well, let's drill in a little bit, as Wes and I promised, about, my goodness, what really is an API? Well, it's not really that different from your physical interfaces on devices, right? When we want to communicate with some network device, we connect to an interface and we start communicating through that interface. That's why they use the word interface here as well. It is a way that we're going to be able to communicate with some oftentimes very sophisticated application by using simple little commands, simple what we call API calls in order to communicate. The most used example on the planet is Google Maps. We all know there's this cool invention of many decades ago now called Google Maps, and we all know that just about every website you go to, especially service-based businesses, they're going to show where they're located on a Google map on their website. What's going on here? Did they make some kind of agreement with Google in order to be able to do this? No. Google was so clever. They developed an API that is freely available for the entire globe to use to be able to go in and communicate with their amazing Google Maps software and place these small maps on everybody's web pages. By the way, think of this for Google. What a great way to further promote their Google Maps product. So it was great for them, great for the end user. So APIs are used just that way to communicate in and out of some sophisticated program.
So I need a piece of software to communicate with another piece of software. I need the communication pipeline, and to make that connection is the API.
You got it.
Very good. So I was wondering, now that we kind of know a little bit about the API term, can we talk a little bit about what is going on between those two interfaces?
Yeah, let's talk a little bit more. Let's drill in to these northbound APIs and southbound APIs. So remember, the northbound APIs are those that are going to be from the applications to the controller, and they're really what make this single pane of glass a possibility. This is a term we're hearing more and more, and what this refers to is being able to manage your entire network by sitting down at one simple, typically web interface. In fact, a web page. We go to a web page, that single pane of glass gives us visibility and management capabilities into all of our stuff. Now notice these APIs at the northbound end, right, between the applications and the SDN controller, they are often REST APIs. And REST APIs or RESTful APIs are very web friendly. They're very internet friendly, and that is why REST APIs are typically found there.
Sure, without getting into, because the technicalities don't really matter here, but it uses a lot like HTTP or HTML language, so we don't have to reinvent the wheel. This is something that, if you're already familiar with it, should give you a familiar way to programmatically control your network.
You better believe it.
Sure.
That's why REST APIs are used, yes. In fact, they're cruddy. The term is CRUD, create, read, update, and delete. That's what RESTful APIs are looking to do. They're looking to create things, read things, update things, delete things for a network configuration. Guess what? That's almost exactly how HTTP works. It updates, it puts, all those verbs that are used in HTTP, they translate beautiful into REST APIs.
Sure. So we've got an intent within the business, that business-driven intent, right? I could come to you as, I don't know, maybe C-level, I'm not C-level, but a C-level person, and I could say, we need to do this. And you're telling me that with a text file, I could throw that against the SDN, provided it's in the right, it's oversimplification, I know, but I could throw it at the SDN, it would ingest that, know exactly what to do, and then through the communication process, configure your network.
You better believe it.
That's awesome.
This becomes extremely flexible. And those single panes of glass, Wes, that I described, and the RESTful APIs, that allows developers to build their own panes of glass. So we're going to be showing here in a couple of moments, we're going to show an actual SDN solution, and just understand that your internal developer staff, if you have a dev staff, they could learn the REST APIs with ease and start building your own custom management interfaces. Another great example of this is maybe we have some junior admins and we don't want to give them access, Wes, to all of the capabilities of management. So we could create a junior admin interface that keeps them out of trouble.
So like a constrained interface, right? You see what I let you see.
Yep, that's exactly right.
Sure.
By the way, I wanted to elaborate quickly on the southbound APIs. So let's dive into that for a second, and then I'll jump over, because I know we want to get to questions, so we're getting close to time. But if we look at the Southbound APIs, just understand, again, these are from the controller down to the devices. And obviously, these are going to facilitate those devices being re-engineered into that intent-based networking and that business purpose. Maybe we need to add a new WAN location because we just obtained another branch office. So these are the types of things that we want the controller pushing down to the devices. Now, what protocols are used here? We said in the northbound APIs, it was often RESTful APIs, but what about the APIs in the southbound? Woo, it's all over the map right now. Let me explain. OpenFlow is an open standard for communicating to controllers down to the devices, but a lot of vendors weren't waiting around, and a lot of vendors wanted to implement their own feature set here. So a lot of these are proprietary. For instance, OpFlex, you see there, that is a Cisco proprietary Java-based API approach for the Southbound API. Junos Space is none other than Juniper's proprietary Southbound API. NetConf it's debatable as to whether that's a Cisco thing or not. Cisco is certainly a huge proponent of NetConf, and other vendors are using it as well, but it's primarily Cisco. So you get the idea. Lots of options in the Southbound API. We'll have to see what happens in the future.
And I think it's great that you help us out with that, you know, because in the early days, the only thing I ever seen, Anthony, in the documentation was OpenFlow. And now I kind of know why, because it was the open standard, but maybe it was moving a little too slow.
Yeah, exactly. So we'll have to see. I think there'll be more standardization as time goes on. And I think there's going to be a lot more cooperation between vendors, just like we saw with cloud, right? With cloud, it was, are you AWS or are you Google or are you Azure? And now more companies are embracing multi-cloud. And so you'll see inside of those three clouds where there's connectors and there's all kinds of tools so they can play nice together. Well, as promised, before we get to any questions that you might have, Wes and I wanted to show you an actual SDN implementation. And the one that we're picking today is software-defined networking SD-WAN from Cisco Systems. So here we can see a single pane of glass approach. Look at all these great monitoring statistics and things that we are going to get. Look at that, transport health data, all this incredible information about our wide area networking connections. This is a beloved approach to the wide area networking portion of your network. I don't care if you're using Cisco's or you're using Juniper's or you're using Aruba Networks or it doesn't matter. SD-WANs are hugely popular. Why? Well, the WAN just hasn't gotten enough love over the years, right? Think about all of the cool inventions surrounding managing your network, and they're all focused on the LAN, the local area network. Well, guess what? It's about time we had sophisticated tools for the WAN. Because of the popularity of cloud, the WAN is a huge hit now. Almost everything we're looking to access is no longer local. So the WAN is finally getting robust tools like this one to manage it. I'll show you around here a little bit. First of all, notice we're at an overview page, but I can easily click and see all the devices that make up this SD-WAN. And as a matter of fact, if I go back to the overview page, Wes, you might remember when I was talking to everyone about the control plane, I said I have just one little box in there to represent the controller. The SD-WAN solution from Cisco, they take the controller and they break it apart into three components. There's a vBond, which ensures there's security in this environment. There's a vSmart, which brings this dashboard to us. And there's a vManage that's actually the controller intelligence.
When they decouple these, do they decouple them in like an OVA, like an open virtual appliance or something? Is that what they are?
That's exactly how they do it.
Okay,
Wes.
interesting.
Yep, that's exactly
so
how they do it.
So it is a piece of software running on a machine somewhere, but nonetheless, it's still a piece of software.
That's right.
Okay.
Yep. And they have all kinds of, as you might guess, positive reasons for decoupling those SDN controllers, components. And one of those is going to be, of course, redundancy. You want to make sure that your SD-WAN solution is always up and running. But boy, oh boy, does this get powerful. Look at this list here. Notice we can monitor, we can configure. There's a toolbox filled with tools that we can use to help manage the WAN. There's a maintenance area where we can reboot devices. We can do software upgrades. We can enhance the security on devices. It's really a remarkable product. Students are always wowed by this. When you go to the monitor area, you can say geography. And look at this. I mean, just being able to visualize your wide area network. Here we are over in Ireland and the UK, and you can see that we have a WAN connection that spans between these locations. I can click on this device right here, and I can see, oh yeah, that's the WAN edge device that I have at 10.10.117, and notice there is a dashboard now that I can go to for that particular device, checking in on its CPU and memory utilization. Notice over here, I can pull up all of the interfaces on this device, and I can see how traffic patterns are occurring. We can see, of course, any faults that might be occurring with the wide area network. So the whole question around an office space of, is the internet down? Well, we are now getting an intense look into the state of the internet thanks to a solution like the SD-WAN.
And this is that application plane that's kind of being abstractly laid over the hardware that you're interacting with. And if I remember right now, you interact with that interface. It takes that RESTful API, generates a command down to the controller. The controller uses whatever proprietary or open standard of the Southbound controller and configures the network according to your intent.
Isn't it cool now?
It's amazing.
And by the way, all of you watching, play with this very SD-WAN that Wes and I are playing with. Let me show you how. Right over here, you will notice that I am at Cisco's developer network. We call it DevNet, Cisco DevNet. So here's what you do. Go ahead and go to developer.cisco.com and create a free account. In fact, I just use my cisco.com free account. So probably do it that way. It's the easiest. Go up to Cisco, register for your free account, and then use that account here. Once you do, go to the sandboxes area, and there is a bunch of sandboxes that are always on. You don't have to schedule them. You don't have to worry about a VPN connection or anything. That's what I did here before our webinar. So if you go in there, you will find that you have access to this always on SD-WAN implementation. Now, because this thing is always on and publicly available for students to play with, it's in a read-only mode. Most of it is in a read-only mode, but it does allow you to go in and monitor it. So you could go in and like play with the Top Talkers feature. Notice we can enable this for monitoring for the last 3 hours. So it allows some configuration, but the main point of this would be you can come in and you can explore what's possible with this SD-WAN solution without paying big bucks to actually acquire the equipment to power this thing.
I'll tell you what, Anthony, just the amount of infrastructure that's behind this interface that we don't realize, and to have access to that. And remember, like Anthony said, go to that Cisco DevNet, create a free account. Yeah. You can log in and you can start assisting your training and you can help yourself. Now, we're going to get to your question. Speaking of training, right? Let's go ahead and, in just a moment, you come back. We're going to answer Anthony, I should say, is going to answer those questions. But first, here's a little bit more about ACI Learning's Network Specialist Program. Check it out.
If you prefer live instruction and would appreciate one-on-one career services support, consider taking our Network Support Specialist program through one of our ACI Learning Hubs. Courses are taught by a live industry expert instructor over a 2-week period and include the cost of one exam attempt. Attend when it works for you, 4 hours per day in the morning, afternoon, or evening. Career Services will help you revise your resume, optimize your LinkedIn profile, and connect you with job opportunities. Ready to learn more? Visit acilearning.com/hubs for more information.
All right, everybody. Thank you. Welcome back to another great ACI webinar, ACI Learning webinar. We're about to take your questions here, so keep those questions coming. We've got some that are already coming in for Mr. Anthony Sequeira, if I can say that right there. So let's go ahead. We've got somebody coming in here. This is Charles from Zoom. Oh, I like this question. This is one of the first things I thought about SDN. It's going to eliminate my job in IT.
Yeah, boy, oh boy. When software-defined networking really started catching on was the big buzz term before AI. This was probably the buzz terminology in our world before AI. That was the number one huge concern, is that, oh my gosh, I learned all of this syntax of Cisco iOS or Juniper's operating system, right? And now I learned all that for nothing. Now someone's going to be sitting at this single pane of glass configuring everything. Well, SDN, software-defined networking, has now been with us for many years. And no, we're not seeing loss of jobs. Think about it. Just because we have this single pane of glass that's going to make maintaining and monitoring and reconfiguring and all that easier with these devices, we still have to have a knowledge of iOS commands and the basics. So no, I really don't see this eliminating jobs. This is very much like when virtualization started to become hugely popular. What happens with information technology from my perspective is that it just is ever changing, right? But there's never been any point where some technology has come along and eliminated positions. Maybe we are there with AI, but I don't know. I haven't researched that enough, and this is not a webinar on AI. I believe we had one of those a few weeks ago, but yeah, AI I'm not going to speak to as far as job loss, but so far with SDN, no one that, and I know so many people that used to be students that are now in the industry, no one's come to me and said, yep, SDN got us all fired. I just don't think it's realistic.
All right, so it's not going anywhere. So here's another question, and Carly, thank you so much. Coming out of Zoom from Carly. Says, can we afford to live without SDN indefinitely?
Yeah, I mean, this is one of those nice to haves, isn't it? But it's certainly not a must have. You know, I mean, it is something that I think a lot of companies are starting to look toward, especially those in like just intense wide area networking environments where they just can't make sense of it anymore. And by the way, we only scratched the surface on SD-WAN. Okay. And that's obviously just one implementation of the SDN. What that product can do is truly remarkable for you. Let me just mention one of them briefly. Here at ACI Learning's Gainesville headquarters, we have wireless internet, we have wired internet, we have private line access. We could have the SD-WAN look at the user traffic and dynamically place that on the correct WAN circuit. So you can build in all of this intelligence into the network thanks to SDN that will really, really make things so much more efficient and optimal. Do companies have to have that? No, they typically want it though. And that's when they go and acquire an SD-WAN type solution.
Very good. Now, another question's coming out here. It says, VA Network Nerd from YouTube, and wants to know, what is the difference? Are we talking about the same thing when we say SDN versus SD-WAN?
Yeah, so SD-WAN is just a subset of software-defined networking. So what ended up happening was SDN is like the umbrella technology term. And companies like Cisco and Juniper started creating solutions that were software defined for just portions of the network. So if you look at Cisco as an example, they invented SD-WAN and they invented SD-Access. So the two of those combined, the local area network and the wide area network, make up the entire network. So it's multiple software-defined products underneath the SDN umbrella.
Very good. Thank you for that question here. Lewis from YouTube, I'm going to go ahead and I'm going to state the issue here first. He says, I see a ton of different SDNs out there, and I'm not sure where to start. And the specific question is, have you used Open Daylight before?
I have not gotten my hands on Open Daylight, but from what I understand, that would be a good place to start. Sure. So it doesn't, I don't think it matters so much where you start with a specific solution, just start, right? And for those of you that may be like thinking about interviewing, right? One of the things that you can do there is I would find out if I'm about to interview with someone, I would find out, are they primarily a Cisco shop, a Juniper shop, an Aruba network shop? You know, kind of investigate what it is that they are using from a networking perspective. And then I would start with that SDN solution, right? So, you know, if you're trying to get that job, you would show up well-versed in things like SD-Access and SD-WAN if they were a Cisco shop.
Very good. Thank you there. I appreciate that question. Johnny from Facebook asks a question, and I'll go ahead and get to what the question is. I need a 60-second sales pitch and why my company should invest in SDN. He says, I have a hard time selling SDN to my coworkers.
Yeah. Well, I would definitely look at the SD-WAN solution. Again, it doesn't have to be the Cisco solution. It could be anyone's SD-WAN that they have developed, because as I alluded to, I think what we're seeing out there in networks today is we're not seeing enough love to the wide area network. So that may be able to help you sell those folks that are controlling budgets on this thing. The WAN is so incredibly critical now, and it hasn't gotten enough love. And companies are very, very sensitive now to, oh my gosh, we have no internet. This is costing us big time money for every minute that the internet is down. Those types of things really beg for the SD-WAN type of a solution.
Most definitely, especially after you manage hard links and all of that. Boy, it'd be nice to just reconfigure it on the fly for sure. So thank you, Johnny, for that question. Appreciate you. David from Zoom, this is a great question here. They're all good questions, but wants to know about the different planes and do they map to an OSI model or do the OSI model, right? Is there any correlation between that? I've got some of my own thoughts, you know, when we talk about the hardware side and the networking side, then we're probably talking like physical and data link layer, but what do you think?
Yeah, that's a really super interesting question.
It is.
When we look at the components of the data plane, it's all of our routers and switches and firewalls and access points. Well, guess what? They're all doing all 7 layers of the OSI model, right? So we can't just be like, oh, okay, the data plane is layers 1 through 2. The controller plane is layers 3. Yeah, it doesn't quite map like that. So this is the one time where I'm saying you might want to set the OSI reference model aside for a moment, because I think it would cause more confusion and more headaches here than it would help us. And by the way, let me just state for the record, I am one of those OSI model nerds. I love it. I have a poster in my house. Just kidding. But I mean, I love the OSI model. And the reason why I love it is it helps me teach networking and it helps me troubleshoot networking. That's why I love it.
One of the first questions I get in troubleshooting is, well, did you check the physical layer?
Exactly.
And that's directly related to the OSI model for sure. Yeah,
That's
I love
exactly right.
I am so glad to hear you say that, because I get a question a lot of times that says, is it even relevant today? It absolutely is. And from the troubleshooting standpoint, I'll tell you right now how many times people, network engineers, and I'm not a network engineer, have come to me and said, did you start at the physical layer? Do you have IP addresses? And you should know where those are. So a great answer there. Here's the $10 million question. I got to ask it like this. What happens if the internet's down?
Yeah.
And let me be specific too, because I didn't give credit where credit's due. This is Paris from Zoom is asking this. What if the internet's down? Can I still access my SDN?
Yeah, that is a great point. And what companies will do is they will have private line access to the controller. So you wouldn't have to rely on a public internet circuit. But I love the question. I love the point. And of course, that same exact question can be asked in a cloud world, right? Everyone's saying, well, cloud's the answer. Public cloud. Public cloud's the answer. Just go to AWS. That's it. That's all you need. Well, most people are getting to the public cloud via a public internet connection. And what the heck do you do if that is down? But to be really serious about the question, yeah, there are designs here that would not require public internet access to be able to continue to manage these components. Thank goodness.
Would we call that OOOOB?
Yeah,
right.
exactly.
So that's out of
real
band. Right, for sure. Thank you so much, Paris. Great question. I've often wondered that myself too, because we always think broad network access. Until you take the network part out of that, then it's no access for sure. And it's good to know that we have options. So we got another one coming in here from Zoom here. This is from Nuruddin. And I hope I got your name right. I apologize if I didn't. Let's talk about automation and alarm systems and integrating that into a ticket system. The question is there any automated alarm generated into a ticketing system or email alerts when there's a change?
That
is a great question.
It's like I planted that question.
It's a great one.
Oh my gosh. First of all, automation. Why is it that so many were fearing their jobs were going to go away? I didn't even bring that up. That's the reason. Software-defined networking fosters automation. That's exactly why many were fearing their job would go away. So thank you for this excellent question. And yes, these tools are making APIs available so that these tools can directly interact with ticketing systems. Absolutely. And notification systems. So one of the most exciting aspects of software-defined networking is these APIs and its openness and all this cool stuff that you can integrate it with. By the way, this is for Cisco, at least speaking from my decades of Cisco experience, this is revolutionary for them to be creating these more open systems. Decades ago, in like 1998, I was teaching Cisco Works, which was a closed proprietary management platform from Cisco. And the big joke, unfortunately, was it doesn't work. So Cisco Works was a really bad name. But now we're seeing Cisco and other vendors really embrace this openness where we can integrate with as many systems as possible.
That's great. That's wonderful. Now, I like it. I'm going to ask you to take the network engineer hat and slide it just to the side and grab that security hat, because the next one is another great question. It says, with gradual implementation of SDN, how does that affect our attack surface?
Yeah, that's a great question. So the attack surface is going to reduce. That is the beauty of this, and that is another excellent benefit. So there are so many tools for security built around the SD-WAN and the SD-Access solutions that we see. And guess what? It's capabilities that we've never had before. Let me just give you an example of one. And again, I'm sorry I'm so Cisco-centric. I really am. I'm kind of embarrassed how much I've brought up Cisco during this presentation because I love many other network vendors. It's just, again, I've had so much experience with Cisco. So those are the examples that I give. But anyways, with that apology aside, if you look at the SD-Access solution, the software-defined networking solution for your local area network, or it's actually for your collection of local area networks in an enterprise. But when you look at that solution, they allow you to incorporate in something called TrustSec. trust security. And what this allows you to do is it allows you to secure the network no longer just using an IP address or a MAC address. So you have tremendous flexibility. I could say, all right, when someone comes to our network, they have to provide a username and password, and then I could make decisions based on that username and password. One of the problems with networking security was it always came down to MAC address or IP address typically. So TrustSec allows all kinds of awesome security based on any attributes that we want to define. It ends up making security much more robust and much more flexible. So I'm very excited to see what is going to happen in the SDN world as far as further enhancements to security.
That's absolutely great that you can implement some kind of conditional access based on attribute, ABAC, I guess is what we say, attribute
any
access control.
attributes. Exactly.
That's really good. So great question, and I did not mention, Scott, thank you so much for tuning in here. Sohail has, from Facebook, has a question, and again, these are such good questions, we got to keep them in here. What are some good resources, you've already named one, for beginners? And I want to go ahead and restate, he already mentioned Cisco DevNet. You can get in there for free, and you can start studying as well. What are some resources for beginners, would you say?
Yeah, I would say that Cisco DevNet is a great one. And I would also look at other vendors because I think they're all starting to copy Cisco on that one, right? They, realized, oh my gosh, we need to set up free training and free sandboxes on our more elaborate solutions. I hate to be biased, but I would also say the IT Pro library here at ACI Learning, right? So we are constantly creating great training on software-defined networking. I would definitely look in our own library here at ACI Learning. And you know what I'm going to do? I'm going to put together a list of resources for our blog because I want to, I'm blanking now on particular texts that I've read that cover this well, but I'll be able to pull those up and we'll do a nice follow-up blog post on great starter SDN resources. Great question.
Yeah, we've got a couple more that this one is Paris from Zoom again asking, and I really want. I'm going to go back to something you stated earlier in the traditional way we used to do things. You talked about being protective of a man in the middle of attack, especially with configurations. This question kind of goes to that northbound communication. How does security work for the Northbound API? If a threat actor got access to it, could they create custom interfaces to monitor and edit the network?
They absolutely could. So we are very, very careful about security for the northbound and the southbound APIs. You better believe it. That's where a ton of our security efforts need to exist. Now, the great news is there are excellent mechanisms for securing those APIs because we have to remember, this is important to remember, RESTful APIs and this concept of using an API to do really exciting, cool stuff, it is not new at all. So there has already been developed great like one-time password and tokenization methods and all these great methods to secure APIs. So that's what they leveraged here. They didn't have to reinvent the wheel. API security is key. It already existed. So that's what we implement in an SDN solution. Terrific question.
Absolutely. You got one here from Promise from Zoom, and it's another good question. It says, do you think SDN is the future and it's going to be here for a while?
I do. I really do. I think we will continue to see, and one of the things that's interesting about that question is we won't really even know they're SDN, right? I mean, we're making a lot of fanfare about this, but that's just going to kind of be, I think, second nature. Like, of course it's SDN. Show me your cool application that controls your devices, right? So yeah, I think this approach is here to stay, just like, of course, cloud and AI and all. Yeah, it's here to stay, and it's going to be really exciting to see where it goes over the upcoming decades.
All right, ladies and gentlemen, we appreciate so much you taking the time to join myself and Anthony. And Anthony, thank you on behalf of our viewers for being here and explaining such a very complex topic. And if you like what you've seen here today, I want to remind you to check out the ACI Learning webpage. And keep in mind, too, that we do stuff across all of the social blogs. So if you want to know what's going on behind the scenes, check us out on YouTube, check us out on LinkedIn, Twitter, Facebook. Look at the social media platforms, and you can find out what's going on behind the scenes here at ACI Learning. On behalf of all of us, thank you for tuning in.